Greetings, math fans. All right, so today we're going to do the derivative of e to the x and a to the x. And actually, depending on on the schedule here, we're either going to call it day 9 or day 10. So we're actually going to I'll start out with calling it day 10. Okay, so this is day 10. And the first is derivative of e to the x. All right, so let's, if I do d by dx of e to the x, let's actually do it using limits, just to kind of start out here. If I do limit as h approaches 0 of e to the x plus h, you guys remember that definition of the derivative, minus e to the x all over h. Okay, and I can factor out an e to the x, so it's limit as h approaches 0 of e to the x times e to the h minus 1. Okay, sometimes people get a little confused by that. Remember, it's like saying, just you actually even putting that together, right? E to the x times e to the h, right? Don't you add the exponents? So I get e to the x plus h. Okay, that's why I can factor out an e to the x. And that's divided by h. And then what I'm going to do is actually just pull the e to the x out in front, and I'm going to have limit as h approaches 0 of e to the h minus 1 over h. All right. So what I want to do now, math fans, I want to investigate this guy right here. Okay, and see what that actually goes to. We can't just do it really algebraically. What we have to do is do it graphically. So let's pull up our graphing calculator and kind of check some things out here. All right, so let's type this in. And of course it's an h, but we're going to use x because that's what we have in our graphing calculator. Okay, so we're going to use parentheses here. So it's going to be second natural log, so e to the x, close parenthesis, minus 1, and then close parenthesis again here. So that's the numerator, and then divided by x. And then we're going to do zoom standard, and that's what my graph is. So that's what's going on. Now obviously, what's going on at 0? Well, actually if I do second calculate at 0, so we're going to do value and then x equals 0, what is y? Well, of course, y doesn't give you anything because it's not defined at 0, right? X equals 0. So the deal is we're trying to find it as h approaches 0. You guys remember from back in the day, right? We're getting closer and closer to it. So, we can zoom in a little bit. If I do, actually I'll do window, and I'll change my window because I want to know what's going on at 0. So how if I set it to like negative 0.1 and the x max as 0.1. So I want to know what's going on at x is equal to 0. And we'll graph it now, see what's going on. That's kind of interesting. So it looks like it's kind of approaching 1, but again, it's not at 1. When it's x equal to 0, it's not at 1, but it looks like it's getting close to 1. So let's look at another way here. Second calculate. Let's do a value. Let's see what's going on at 0.0 when x is really close to 1, or 0, right? 1.0005. So it looks like it's getting closer and closer to 1. Let's look at the other side here. So second calculate value. Let's look at negative 0.000001. See what's going on. 1. Okay, so it looks like it's going to 1, and that's important. So let's close this up here. And this guy, as h approaches 0, it's equal to 1. So really, I can say it's e to the x times 1. So let's cursor down. All right, I'll just move it over here. So really, the derivative, d by dx of e to the x is just e to the x. Very interesting. So, using the chain rule, because make sure you use that, it's very important. We're going to say d by dx of e to the u is, of course, just e to the u, and then using the chain rule is du dx. Okay, very important. But the derivative of e to the x is e to the x. It's really very simple. So let's try a couple examples here. Well, my first example is really boring because it's just derivative of e to the x is e to the x. Okay, so you already know that. So I'm just going to write out here d by dx of e to the x equals e to the x. That's really fast. Okay, let's try another example. D by dx of e to the 2x. Okay, well that's just, again, the derivative of that is e to the 2x, but then you got to do the chain rule, and so basically you're taking the derivative of 2x, which is 2. And please put it in the correct order now, so you're going to have 2e to the 2x, so that's your answer. Okay, pretty easy. Here's another example, d by dx of e to the 2x squared minus 3x. Okay, once again, it's just you're repeating the e to the 2x squared minus 3x again. So it's e to the 2x squared minus 3x. And then the chain rule, so it's the derivative of that top part here, which is just using the power rule, right? It's just going to be 4x minus 3. So again, put this in a nice order. You have 4x minus 3, e to the 2x squared minus 3x. Okay, that's pretty easy. Let's try another example here. D by dx of e to the square root of x squared minus 3. Okay, well again, that's really easy. It's e to the square root of x squared minus 3. And now think of this as, right, that always is very helpful, x squared minus 3 to the 1/2 power. So that's going to be the derivative of x squared minus 3 to the 1/2 power is 1/2 times x squared minus 3 to the negative 1/2 power. Okay, again, we're doing the chain rule, so now we're working our way in. So the next one is derivative of x squared minus 3, which is 2x. Okay, and then I can rewrite it as 1/2 times 2x is just x. So I get x times e to the square root of x squared minus 3. Right? And then this bottom, this x squared minus 3 to the negative 1/2 just goes in the bottom. So we get the square root of x squared minus 3. Okay? And that is the derivative. All right, cool. Okay, let's kind of just keep going down here. And I'll try another one here. How about d by dx of e to the e to the 2x. Ooh, very interesting. Very interesting. Well, that is going to be equal to e to the 2x. Do you agree with that? That's the first part. Because the derivative is just e to the x of derivative of e to the x is just e to the x. So it's like you're repeating it every time. Well, now what I can do is I can take the derivative of this guy right here. What's the derivative of e to the 2x? It's just e to the 2x. And now I'm going to look at the 2x. What's the derivative of 2x? It's 2. Okay, so my final answer then is 2 e to the 2x e to the 2x. Looks a little complicated, but actually it's pretty easy. Okay, let's keep going here. How about d by dx of e squared of x? All right. Now, I know some of you guys are going, oh, it's, you're going to look at that e and you're going to take the derivative. But what you need to realize, math fans, is that e squared is a constant. It's like me telling you what's d by dx of 5x. What is it? 5. Right? So what's the derivative of that constant times x? It's just e squared. Okay, don't get faked out by always saying, oh, it's got to be the same thing. As it's e to the x, derivative of e to the x, e to the x. This is not a variable there. This is a constant. All right, so that's really important you guys understand that. All right. Try another one here. D by dx of 3x squared e to the 2x minus 6x cubed e to the 1/2 x. Brutal! Brutal, man. Brutal. Okay. We're going to just use some of the properties that we know already. No big deal. Like the first one, of course, I'm going to break this up into two separate derivatives, right? The first part and the second part. So if I take the derivative of the first part, it's just using the product rule because that's what this is. 3x squared times e to the 2x. So it's the first, which is 3x squared, times derivative of the second, which is e to the 2x times 2, plus the second e to the 2x times derivative of the first, which is 6x. It's not that big of a deal. And then it's minus, and I'm going to put this in parentheses here because people sometimes forget that. It's minus, and then you're going to take the derivative and then distribute the negative. All right, so again, it's got the product rule here. So it's the first, which is 6x cubed, times derivative of the second, which is e to the 1/2 x. Derivative of 1/2, x is 1/2, so it's times 1/2. Plus the second, so plus e to the 1/2 x, times derivative of the first, which is 18x squared. And again, I'm not worrying about the negative because I dealt with the negative right here. Okay, so don't, you could deal with the negative each time, but I'm just dealing with the n. All right, so let's put some stuff together here. And for the first part, I've got, of course, it's multiplication for the first part, so it's going to give me 6x squared e to the 2x, okay, plus 6x e to the 2x. And then it's going to be minus 3, right, 1/2 times 6 is 3, x cubed e to the 1/2 x. And then again, that negative goes to both terms, so it's minus 18x squared e to the 1/2 x. Okay, and you really can't put anything together. So that, math fans, is your final answer. Kind of big and evil and nasty, but that's cool. Okay, let's try another one here. Just a bunch of examples. So d by dx of e to the sine of 2x. All right, well, again, just, got to use your chain rule here, but it's going to be e to the sine of 2x. And then you take the derivative of sine of 2x, which is going to be cosine of 2x. Okay, and then take the derivative of 2x, which is going to be 2. So I put this all together, I get 2 cosine of 2x e to the sine of 2x. All right, that's not too bad, not too shabby. All right, so let's that's done. We're done with e. Now I want to do the derivative of a to the x. So let's clear this out here. And derivative of a to the x. And math fans, it's important to understand a is a constant. It's like 2 to the x, 4 to the x, okay? It's definitely a constant. There are not two variables in here. We're actually going to do a problem when we do logs where we have x to the x. And that's, it's a little more complicated, but not that big of a deal. All right. I'm going to use some properties of logs here to kind of figure things out here. So we're going to use properties of logs to write in terms of e to the x. So what I want you to remember that e to the ln of a is equal to a, right? E to a, as long as it's e, you have e and you have ln of a, it's equal to a. Okay, just to show you that is true, right? If I have e to the ln, let's just do x. E to the ln of x should be equal to just x. Let's take the natural log. So let's say it's equal. It should be equal to x. Let's take the natural log of both sides. Okay, and what happens? Then that moves to the front, right? And I get ln of x times ln of e equals ln of x. What's natural log of e? 1. ln of x equals ln of x. Sweet. Okay, so that's why I can actually say e to the ln of a is equal to a. All right. So e to the ln of a to the x right? So whatever that value is, isn't that just equal to a to the x, right? No matter what. It could be anything ln of whatever, it's equal to that value, a to the x. All right. Another way we can write this, so another way to write e to the ln of a to the x is I can bring that x down to the front. Do you guys agree with that? That's kind of your properties of logs. So I can write e to the x ln of a. Well, that's no big deal. It's your power property, right? Bring that exponent down. Again, our properties of logs. Okay, so then I can say d by dx of a to the x is equal to d by dx of e to the ln of a to the x, which of course is, we'll put it into this form because this is the form I really want to have here. It's going to be d by dx of e to the l or x ln of a. That's really what we're working with. Okay, and now it's actually easy, pretty easy to take that derivative. D by dx of e to the x ln of a, let's write that over here, is equal to e to the x ln of a. Right? It's, remember, derivative of e to whatever it is the same thing as e to that whatever. Okay, times, and let me just show a little work here. D by dx of x ln of a. Right, so so it's using the chain rule, right? I have to take the derivative of that exponent now. So let's keep going here. It's e to the x ln of a. And what's the derivative with respect to x of x ln of a? Well, do you guys realize that this is a constant? So it's like saying the derivative of 5x is what? 5. So the derivative of x ln of a is just ln of a. All right. So now let's actually go back and substitute. It's getting a little messy here, but e to the x ln of a, which is right here. If I can substitute this back in again, so a to the x, and so that's equal to a to the x ln of a. That's actually my ultimate equation here. Then of course if I do the chain rule, here's your with u, it's d by dx of a to the u is equal to a to the u ln of a du dx. And that, math fans, is your final answer. So really what you need to remember here is that you have a derivative of a constant to an exponent. It's equal to that same value, a to the u, and then natural log of the natural log of the base. Don't get confused. Sometimes people try to take the natural log of the exponent. It's the natural log of that base. So these values are the same. Okay, a to the u times ln of a. So let's do an example here now. We have d by dx of 3 to the x. Okay, pretty easy. It's just 3 to the x. So it's like you're repeating it again, right? As a to the u is, there's your a to the u again, times natural log of the base. So ln of 3. That's it. Oh man, that was really nice. Okay, let's do another one here. D by dx of 5 to the negative x. Well, it's 5 to the negative x times natural log of 5, but we're still taking the derivative, right? We're using the chain rule, and so derivative of negative x is negative 1. Okay, so your answer is negative 5 to the negative x times natural log of 5. Okay, not bad. Let's keep going here. D by dx of 105, sweet, sine to the 4th of 3x. Looks a little brutal. Not really though. So of course that's just going to be 105 to the sine to the 4th of 3x. And then you just got to start, and we have to do, of course, natural log of 105. And then we got to start using our chain rule. What's the derivative of sine to the fourth? Remember, that's going to be written as sine of 3x to the fourth. So it's going to be times 4 sine cubed of 3x. Okay, and you're working your way in. What's the next one? Oh, that's what's derivative of sine of 3x? Cosine of 3x. And what's derivative? Now we got to keep going one more notch in there. What's sine of it's derivative of 3x? 3. Okay, so we put all that together. Basically, let's see. The only thing we can multiply is the 4 times 3. So we're going to equal 12 sine cubed of 3x cosine of 3x natural log of 105 times, I'm just going to use the times here, so 105 sine to the fourth of 3x. Brutal, brutal on multiplication here, though. And that's it. That's your answer. Okay, kind of large looking, but it's what it is, math fans. Okay, here's another example for you. Y is equal to x to the root 7. And some of you guys are going, oh man, okay. So we got to use logs and this. No, we don't have to use logs. Guys, this is like saying, if I said what's y, you get y equals x squared, what's the derivative? Don't you take that and move it to the front and then reduce the power by 1, so it's equal to 2x to the first or 2x? Okay, so dy dx is equal to, this goes to the front, so it's root 7 x to the, what do you do with the exponent? Subtract 1. Oh, that's it. That was actually pretty easy. Okay, but you got to remember the rules. Okay, let us do another example here. Y equals x to the e squared power. All right, and again, you're going, oh man, this is kind of brutal. But remember, it's the same thing as the example before. Okay, it's not a to the x, because a to the x means it's like 3 to the x power where you have a constant here. That's not a constant. This is just like the one before. This is like saying x to the 10th power. You move this to the front. So 10x to the 9th power, right? So dy dx, I move that to the front, so I get e squared x. And what do? You subtract 1. So it's e, because that's a constant, right? E squared. So it's e squared minus 1. So that's your answer. Sweet. So don't use the chain rule here, because there's not a chain rule. It's just a constant, so no chain rule. Very sad. Okay, because e squared is a constant. Sweet. Okay, the next one I want to do with you guys is, this is one of your homework problems. And it's on page 179, I believe. All right, and this is number 49. And this is what it says. It says, find the equation. It's a great problem of a line that is tangent to y equals e to the x and passes through the origin. Okay, this is kind of a cool problem. So if I would make a quick sketch here, okay, this is basically what e to the x looks like. Something like that, right? It's an exponential function. And it's passing this, the equation I'm looking for passes through the origin, which of course is 0, 0. And some other point here. It's got to be tangent to it. So that's what I'm looking for. Okay, it's going to pass something like that. That's what your line looks like. So I'm looking for that value. So this is the deal. We really kind of need to know that coordinate because we need to kind of come up with the slope of a line here. Okay, and that coordinate we're just going to call x, comma, and then when you plug it x into there, right, it's your e to the x. isn't it just going to be x comma e to the x? Okay, so we already know to find the slope is just going to be the derivative of our function. And so that means it's just going to be e to the x. That's our slope of the tangent line. Okay. Now don't plug in 0, 0 because 0, 0 is not on that curve. It's a coordinate that we're looking at going through. Okay, that's kind of important that you don't do that. So it's equal to e to the x. And what I want you guys to do is we're going to use the yox here. And you guys know the yox is y2 minus y1. So in this case here, when we say y2, it's going to be e to the x minus 0 over x minus 0. Do you guys agree with that? Because I have 2 points now, this one and this one. And what does that equal to? That equals e to the x, right? It equals that guy right there. So of course now I just have e to the x over x equals e to the x. And I can cross multiply if I want. Or I can just divide both sides by e to the x, right? The e to the x cancels. So well, let's do x e to the x equals e to the x. So do you guys agree x equals 1? So that's nice. That's my coordinate. And so I can do a couple of different things here. First of all, here's my coordinate. Let me kind of move down a little bit. My coordinate is going to be 1 comma. If I plug in a 1 into the y value, it's e to the 1 or e. So this is my coordinate. And then, of course, I can also plug it into my slope. So my slope is e. Okay? And then let's do point slope form. So it's y minus e equals m times x minus 1. So we get y minus e, right? That's point slope form, which is cool. But if I simplify it a little more, ex minus e, and then I add e to both sides, and I get y is equal to ex. Not e to the x, but ex, and that's the equation of that line. Okay, it's a really, really good problem. I really like that problem. Okay, but that is that's your answer to number 49. All right, anyway, that's it, math fans. I hope you guys learned a little bit about derivatives of e to the x and a to the x. And, you know, just again, watch the chain rule. People always mess up with the chain rule, forgetting to keep taking the derivative until you're done. All right, that's it, math fans. Have a great day. Adios. Goodbye.